Russia believed it had found the formula. Saturate Ukrainian skies with cheap, expendable drones, hundreds of them every night, overwhelm the air defense network, drain the missile stockpiles, grind down the infrastructure, grind down the population. It was a straightforward attrition strategy, and for a period it was producing results. Then Ukraine did something that caught everyone off guard. Not Russia, not NATO planners, not the Pentagon. Nobody saw it coming. Ukrainian engineers took an aircraft older than most of the people currently flying it, a plane never conceived as a weapons platform, a plane that most professional air forces would have retired and scrapped 2 decades ago, and transformed it into one of the most operationally effective drone killing systems active in any conflict zone on Earth right now. Russia has no answer for it. No doctrine, no countermeasure, no equivalent. What Ukraine has engineered here is not a tactical improvisation. It is a conceptual shift that is going to reshape how every serious military on the planet thinks about air defense going forward. And it began with an aircraft that first flew in 1969. Before walking through what was built and why it matters, one thing needs to be stated directly. What Ukraine has done with this platform is not a curiosity or a novelty. It is a working solution to one of the defining military problems of the coming decade, developed not by a billion-dollar defense contractor, but by civilian volunteers working with a half-century-old transport aircraft. This is the kind of development that tends to be overlooked until everyone is copying it. To understand why this solution carries the significance it does, the scale of the problem it addresses needs to be stated plainly. Russia is currently manufacturing Shahed drones at a rate of approximately 4,800 units per month, a figure that continues to climb. Moscow has announced intentions to scale that output dramatically, which would put monthly production at roughly 14,000 or more within the coming year. That translates to over 450 drones per day entering Ukrainian airspace, more than 18 per hour continuously around the clock. Now consider the economics of intercepting them through conventional means. A standard surface-to-air missile of the type Ukraine has been deploying since the opening phase of the war costs somewhere between $500,000 and $1 million per engagement. A Shahed costs Russia between $20,000 and $45,000 to produce and field. The arithmetic is not complicated. If Ukraine fires $1 million interceptor at every $40,000 drone Russia launches, Russia wins a war of economic attrition without ever needing to achieve a decisive battlefield result. It drains Ukraine's defense budget one interception at a time. Ukrainian military planners recognized this structural imbalance early. Their response was not to request more expensive missiles from Western partners and continue burning through them at an unsustainable rate. They reframed the question entirely. Not how to shoot down more drones, but how to shoot down more drones for less money, more quickly, more reliably, in greater numbers, using assets already in the inventory. That question led to a breakthrough that no one else in the international defense community had arrived at. The platform at the center of it is a twin-engine turboprop utility aircraft that made its maiden flight 57 years ago, the Antonov An-28. For anyone unfamiliar with it, the An-28 is not a celebrated aircraft. It is not a fighter, not a bomber, not anything that appears in serious military aviation literature. It is a short-range utility transport designed to move cargo, mail, and small passenger loads between remote airstrips too short or unprepared to receive anything larger. Roughly 190 were produced over its production run. Today, fewer than 15 remain operational anywhere in the world. Some continue in commercial service across parts of the former Soviet space. A small number serve in military utility roles in several smaller air forces, including Ukraine's. There is nothing in the An-28's original design specification that suggests weapons capability. No hardpoints, no fire control architecture, no targeting radar, no gun mounts. Just a small, reliable, unglamorous aircraft doing a simple job without ceremony. That is precisely what makes what Ukraine's engineers did with it so instructive. When they looked at the An-28, they did not see an obsolete utility airframe. They saw a platform. They saw a delivery mechanism. They saw a way to bring interceptor capability directly to where the threat operates, in the air, at night, over Ukrainian cities, that no one else had pursued because no one else was operating under conditions that demanded this level of improvisation under pressure. The world got its first public confirmation of what had been done in February 2026, when French broadcaster TF1 aired footage of one of these aircraft on an active nighttime combat mission over the Kiev region. What viewers saw attached to the cabin door was not what anyone expected. A 6-barreled rotary weapon, specifically a 7.62 mm M134 minigun, one of the most capable rapid-fire systems ever developed for aerial application. The M134 cycles between 3,000 and 6,000 rounds per minute, delivering up to 100 rounds per second. Its historical applications include the AC-47 Spooky gunship and various side-firing aircraft configurations across multiple decades. Its traditional purpose was ground suppression. Ukraine redirected it skyward. The TF-1 footage revealed something else that immediately drew analytical attention. Painted beneath the cockpit were silhouettes, small outlined shapes representing Shahed and Garand-type drones, one for each confirmed aerial kill. At the time of filming, there were just over 110 of them. 2 were marked in yellow, believed to indicate an exceptionally high kill count from individual engagements. The report confirmed that the aircraft and its 4-person crew had destroyed close to 140 Russian drones in total by the time the cameras arrived on site. More than 100 drones eliminated by a modified 1969 cargo aircraft crewed by 4 people, the majority of whom are not professional military aviators but civilian volunteers who chose to take this aircraft into airspace, where Russian cruise missiles and increasingly capable armed drones operate every night. They fly in an aircraft with no armor plating, no electronic countermeasures, and no ejection systems. Every flight is a deliberate choice made with complete awareness of what the airspace contains. The operational system built around the An-28 is more sophisticated than its appearance suggests. The aircraft maintains continuous communication with ground-based controllers monitoring Ukrainian airspace in real time, tracking incoming formations, and passing targeting data directly to the crew. When a Shahed swarm is detected moving toward a defended area, ground control directs the An-28 to the intercept zone. On board, a camera operator monitors a live infrared feed from an exterior sensor scanning the surrounding sky for heat signatures. The pilot manages positioning and responds to crew direction. A dedicated gunner equipped with night vision operates the minigun and engages targets as they enter effective range. A 4th crew member handles support functions including clearing jams and managing the ammunition supply. By early 2026, Russia had begun equipping certain drone variants with man-portable air defense systems and R-60 air-to-air missiles, weapons specifically designed to engage manned aircraft. The drones the An-28 is hunting are, in specific cases, now hunting back. The crew is aware of this. The silhouettes on the nose continue to accumulate regardless. Then, in April 2026, the program moved into a fundamentally different operational category. Pilot and volunteer Timur Fatkulin released new footage of the An-28 that confirmed a significant structural modification. Underwing hardpoints had been installed on both wings, mounting points of the kind found on fighter jets and attack helicopters, entirely absent from the original design. Ukraine's engineers had added them from scratch. Onto those hardpoints, 2 distinct interceptor drone systems had been mounted, converting the An-28 from an airborne gunship into an airborne drone launch platform. The 2 systems now integrated into the An-28's loadout are the Skyfall P-1 Sun and the MIROPS AS-3 Surveyor. They represent different engineering approaches to the same operational problem. The P-1 Sun is built around a compact bullet-profile airframe constructed from a modular 3-dimensionally printed structure that makes it fast and inexpensive to produce at volume. Cruise speed runs at approximately 280 kilometers per hour, with a maximum intercept speed pushing toward 430 kilometers per hour, sufficient to close with virtually any UAV in current Russian operational service. The figure that reshapes the strategic calculation is the unit cost, approximately $1,000 per interceptor. Against a Shahed costing Russia between $20,000 and $45,000, every successful P-1 Sun intercept represents a cost-exchange ratio of between 20-1 and 45-1 in Ukraine's favor. The manufacturer has indicated production capacity of up to 50,000 units per month. If that capacity is realized and deployed at scale, it fundamentally restructures the financial logic of the drone campaign Russia has been running since 2022. The MIROPS AS-3 Surveyor addresses a different part of the threat spectrum. Where the P-1 Sun is optimized for cost efficiency against the high-volume end of Russia's drone inventory, the AS-3 was designed for more capable and sophisticated targets. Developed by Perennial Autonomy, a California-based defense company, it carries an operational range of approximately 18 kilometers, reaches speeds of around 260 kilometers per hour, and delivers a 2-kilogram warhead configurable for direct impact or proximity detonation. Its most significant characteristic is an artificial intelligence guidance architecture allowing fully autonomous operation, identifying, tracking, and intercepting targets using onboard sensors with no manual pilot input required. Ukraine has been fielding MIROP systems since late 2024. Their operational record has drawn sufficient international attention that AS-3 units have reportedly been transferred to NATO partners along the alliance's eastern flank as part of broader air defense cooperation arrangements. Current unit cost sits at approximately $15,000, with production scaling potentially bringing that to around $3,000 per unit. Both systems are now being launched not from ground batteries, but from altitude, from a modified 1969 transport aircraft conducting combat air patrols over defended Ukrainian territory at night. The April 2026 footage confirms operational validation. The strategic advantages embedded in this architecture deserve systematic examination because they explain the level of attention this program is receiving from defense establishments well beyond Ukraine's borders. The first is altitude and proximity. Ground-launched interceptors face an inherent geometric constraint. A Shahed cruising toward a target is already at operational altitude. A ground-based system must climb to intercept geometry before the engagement sequence can even begin, and that climb consumes time that the threat's proximity may not allow. The An-28 eliminates this constraint entirely. The aircraft is already airborne, already at the relevant altitude, already within the operational zone where the threat is moving. When a contact is called in and the infrared sensor identifies the heat signature, the interceptor launches directly into viable intercept geometry. The April footage shows the full sequence. A P-1 Sun leaves the hardpoint, closes the distance, detonates, and the Russian drone is gone. The engagement takes seconds from launch to intercept. The second is loiter endurance. Interceptor drones are high-performance but short-duration assets. A ground-launched interceptor swarm cannot patrol a defended area and wait for threats to arrive because the interceptors will exhaust their energy reserves before the threat appears. This forces reactive launch sequences that reintroduce the time problem. The An-28 carries no equivalent constraint. It can maintain a standing patrol over a power station, a water facility, or a rail junction for hours, ready to deploy interceptors the moment ground control identifies an inbound contact. Standing combat air patrol capability previously associated only with expensive fighter aircraft is now being delivered by a modified cargo plane and $1,000 drones. The third is configurability. The hardpoints added to the An-28 are not locked to specific systems. They accommodate different interceptor types based on mission profile and anticipated threat composition. High-volume Shahed swarms call for P-1 Sun saturation. More capable Russian UAVs call for the AS-3's autonomous precision. The same architecture could accommodate rocket pods, additional gun systems, or next-generation interceptors as they enter the inventory. The platform adapts to threat evolution rather than being fixed to a single capability profile. The fourth is basing flexibility. The An-28 was designed from the outset for short, unprepared airstrips. It does not require the runway length or prepared surface of a conventional military installation. It can operate from a field, a road segment, or a makeshift strip in open country. In a conflict environment where strikes have degraded many primary Ukrainian airfields, the ability to base air defense assets at almost any suitable location across the country is not a minor convenience. It is a genuine strategic multiplier. By April 2026, Fatkulin confirmed the An-28 had accumulated 222 confirmed kills using the minigun system alone, a figure that does not yet include intercepts achieved through the newly mounted interceptor drone systems. He described the air-launched P-1 Sun as a cheap air-to-air missile already proven under live combat conditions. That description is worth holding against its institutional context. This capability was not produced by a major defense contractor under a large government research program. The United States military, operating the largest defense budget in recorded history, does not currently field a combat-proven operational equivalent. The Pentagon has no active system comparable to what Ukraine assembled from a transport aircraft built in the late 1960s and commercially available components. The An-28 is one node within a broader air defense ecosystem Ukraine has been constructing under live fire conditions across 3 years of sustained drone campaign. The network today includes mobile ground-based interceptor units, AI-powered autonomous turrets capable of engaging targets without human authorization, directed energy platforms including laser and high-powered microwave systems that disable drone electronics without firing a projectile, and now airborne launch platforms operating at altitude over defended areas. These systems share data with ground controllers coordinating the overall defense picture in real time. The interceptor layer has become critical to cost sustainability across the entire network because every Shahed destroyed by a $1,000 P-1 Sun is a Shahed that does not consume a Patriot interceptor costing $2 million. Those rounds stay in the launcher, available for the cruise missiles and ballistic warheads that actually justify their expense. Ukraine is deliberately diversifying its interceptor portfolio to prevent Russia from developing a unified countermeasure. The P-1 Sun, the Strela, and the Syrio-8, a quadrotor platform using advanced AI to engage Shaheds with no human in the loop at any point, each present different intercept geometries, different electronic signatures, and different operational profiles. No single Russian countermeasure defeats all of them simultaneously. And Ukraine is not only diversifying what it deploys, but from where. The An-28 demonstrates that the launch platform itself is a design variable. Ukraine is already operating mothership drones, larger UAVs carrying and deploying smaller interceptors in contested airspace. Light aircraft and helicopters are currently credited with accounting for approximately 12% of all Russian drones entering Ukrainian airspace. Systematic upgrading of those platforms with interceptor drone payloads, using the approach validated by the An-28, could push that figure considerably higher. Ukrainian engineers are reportedly evaluating the concept's application to transport helicopters and Yak-52 trainer aircraft, both of which offer the small footprint and field-basing flexibility that makes the An-28 program viable. Russia is not static in response. By early 2026, confirmed reporting indicated that drone variants had been equipped with man-pad systems and R-60 air-to-air missiles, specifically designed to engage the manned aircraft hunting them. New drone variants are being developed with self-protection systems intended to reduce vulnerability to the intercept geometries Ukraine's network is optimized for. And the trajectory toward 14,000 or more Shaheds per month, if realized, would impose a simultaneous threat volume that no single layer of the defense architecture could absorb alone. The full network, every layer operating simultaneously every night, is not a design preference. It is the operational minimum. The network is holding. The adaptation rate is keeping pace with the escalation rate. The An-28, with its hand-painted kill silhouettes and field-installed hardpoints and civilian volunteer crew, remains the most visible demonstration of what that adaptation looks like when it is working. The significance of what is being developed in Ukrainian airspace extends well beyond this conflict. Every serious defense establishment is studying it because the challenge Ukraine is solving, defending against mass-produced low-cost GPS-guided drones at scale, is not unique to this war. It is the defining air defense problem of the next generation of conflict. The question every defense ministry is currently wrestling with is who solves it first and most effectively. The current answer is a country under existential military pressure, operating a transport aircraft that first flew before most current heads of state were born, crewed by civilian volunteers who painted kill marks on the nose because no standard military stencil existed for what they were doing, because no one had done it before. If this gave you a clearer picture of how military innovation actually works under pressure, share it with someone still reading the surface-level coverage. And if you want analysis that goes into the operational mechanics rather than just the headline numbers, follow along. There is considerably more to unpack.